Some of the most common skills we use on Earth prove to be much more tedious in microgravity, but they are skills that astronauts must be able to master as we journey farther into space. An experiment called Fine Motor Skills is the first to measure long-term microgravity exposure, different phases of adaptation, and sensory motor recovery after returning to Earth. My colleague Lori Meggs at the Marshall Space Flight Center in Huntsville, Alabama, spoke with Christina Holden, the principal investigator of this study, to learn more.
We're interested in finding out if there are any effects of long-duration microgravity on fine motor skills. We're particularly interested in looking at advanced technologies like touchscreens and gesture devices because we think those are the kind of devices that crew members will be using on future missions. And we want to make sure that if they're on a long-duration journey to Mars, for example, that they're able to interact accurately with those devices once they go to the planet's surface.
What types of fine motor skills are we talking about?
So we are doing this study on an Apple iPad and using the touch screen. And so we have 4 different tasks that are part of the investigation. They include things like pointing to a target, dragging to a target, shape tracing, a circle and square shape tracing, and then a pinch rotate task, which is a multi-touch task for the touch screen.
Why do we need to know this?
Well, so crew members more and more are using iPads on board ISS, and so they're using a lot of touchscreen interfaces. And a lot of times, if interfaces aren't designed well, there are a lot of errors. And so we want to make sure we know if there's any performance decrements after being in microgravity for a long time that we might need to accommodate with a different type of design.
Would this lead to new designs for our iPads on Earth?
Yes, we're very excited about that. Actually, the particular application we think it has is for populations who do have problems with fine motor skills. So we're looking into using the test battery that we've developed for elderly populations or brain injured or Parkinson's patients who need to be tested. You know, it could be used as a diagnostic tool. We also think it could be used as a rehabilitation tool.
Really cool.
It's really cool. We have a couple of universities that are very interested in working with us to kind of move the product in that direction.
So have you done other studies like this?
We've done a number of ground studies looking at fine motor skills, but this is really the first flight study that we've done.
Pretty exciting that you can do it for a year, right?
It is so exciting. You know, we come from Human Factors and we don't get to do a lot of flight studies. And so we are thrilled to be part of the one-year mission. This is a really great opportunity to complete a data set that is a little bit lacking. So there's been some data in the past on fine motor skills, not interacting with the kind of devices that we're using, but also with a lot of lapses in the data, you know, over the mission. And so this is a great opportunity for us to get data pre-flight, throughout a whole one-year mission, and post-flight. And I think it'll tell a really, really neat story.